Hello everyone, let's graph some exponential functions and see if we can write an equation that goes with them. So the first thing you need to realize is that I will give you sort of the structure of the function that I'm asking you to find. Whatever it looks like, I'm telling you it's going to look f of x equals, it's just a base to a power. So if it helps you to kind of think of it as y equals a to the x, fine, it's input output, it's not a big deal. The output here is 9. I don't know I don't know the base of the exponent, but I do know that x is 2. So what I'm doing is plugging in my xy pair into my sort of structure, and I'm going to figure out what I don't know. I don't know a. Well, yeah, I do. It's 3. A equals 3. So what this is saying is, if a is 3, then you would say f of x equals a is 3, 3 to the x. That is the graph right there of 3 to the x, because 3 squared is 9. Let's do another one. So let's see. We know it's y equals a to the x, so I'll plug in my y value, which is 1/5, and a to the negative first. Now, there's a couple ways you can do this. One of them is to just realize that a to the negative first is 1 over a. That's what that means. And now you could cross multiply and solve, but I want you to kind of just be able to look at it and realize that if you have these two things in the denominator, that must mean that a has to be 5. Okay, this is a sort of an equivalence thing. If you were to cross multiply, you get 5 equals a, you get the same thing. But I want you to kind of start to use your brain to think these through. These negative exponents can be tricky. So this would be y equals 5 to the x. 5 to the negative first is 1/5. Remember, negative exponents mean I'm on the wrong side of the fraction bar. So move me to the bottom and I'll be happy and positive. Let's try a couple more. If it's y equals a to the x, 1/16 equals a to the second. Square root both sides. Square root 1/16 is 1/4. So y equals 1/4 to the x. 8 equals a to the negative third. So I'm going to write this again like 8 equals 1 over a cubed. And then I'll start to kind of, maybe I'll just solve it. So multiply both sides by a cubed. Divide both sides by 8, then cube root. And the cube root of 8 is 2. So this is 1/2. So this is 1/2 to the x, the function y equals, that's one of our parent functions that we do is 1/2. This is tricky to reason through sometimes, but if you start off with this, then you're just creating essentially a proportion. 8a cubed equals 1, divide, cube root, okay, cool. So a is 1/2. Now remember, a is not going to be negative. The base of our exponents is not going to be negative for any of these problems. So even though technically, like for this one, you can have a plus or minus, no, you don't. It's just plus. Okay, now let's do one where I give you a different format. This is c times a to the x. So y equals c times a to the x. You just have to remember that c is your initial amount. What are you starting with when no time has passed? AKA, what's the y-intercept? So the y value here is 12. C, your initial amount, is 3. Look, in the other ones, it was 1 both times. So this says different because it's 3 is your y-intercept. Times, I don't know a, but I do know that x is 2 in this problem. Divide both sides by 3. 4 equals a squared. A equals 2. So my equation would be 3 times 2 to the x. C is 3. A is 2. One more. 15 equals, that's the y value, c is 5. Oops, c times a to the how many? Negative 1. Okay. So divide both sides by 5. 3 equals a to the negative first. And then I'll do this again. 3 equals 1 over a. Now, you could cross multiply, or you could think of it as a proportion. That means 3a equals 1, so a is 1/3. So this one would be 5 times 1/3 to the x. I'm going to put parentheses there. Okay. So that is our equation for this graph. And notice again, I have to tell you what it's going to look like, or you won't be able to plug stuff in if I don't give you sort of the structure of the function. So I'll always tell you what it looks like, and then you need to plug stuff in according to how it looks. The other thing you might be asked to do is take a model and answer some questions. So this is talking about some drugs in your system, and we're trying to figure out how many milligrams are left after 3 hours. If you're going to go into medicine, this is probably very important, because if you get it wrong, then the patient might die. So make sure you know how much blood is in their system and all that. I'm going to graph this in Desmos. So let's see, I got two of them. I think that's the second one. Yeah, here's the first one. Wait for that. All right, here's my graph. So that's the function. This is saying how much blood is in the patient's system, and you'll notice it starts at 50 because in this problem, this is A times B to the X. A is 50. The start is 50 in this problem. How many is it? How many milligrams are in their bloodstream after 3 hours? You could do this two ways, or maybe more than that. You could probably just kind of guess and check your way through it, like find 3. There it is, 27.441. Or you could even use like just basic Desmos skills, like that's an X value. What happens when X equals 3? Then the Y value is 27.4. Or it's function notation, and Desmos is cool like that. If you say plug 3 in to that function, I'll say D of 3, it'll do it for you, 27.44. So how many milligrams are left in the patient's system? 27.44 milligrams after 3 hours. It was 50, now it's down to 27. The other question is a skydiving problem. So here's your equation, and I will graph that. And it looks like this. And you're like, oh, cool. And the first question is, what is the initial velocity? Now, it's tempting to say 80, but you got to be careful in this problem. It's a slightly different function. So when you look at the graph, oh, it's 0. Okay. No time has passed. You have 0 velocity. That's essentially you sitting on the plane waiting to jump out of it. So 0 feet per second. And when you do jump out of it, you're not like jumping with like force. You're not like pushing off the plane to go faster when you fall. You're just hopping, and then gravity is the only thing that pulls you down. So there is no initial velocity. It's just, I'm going to fall. That's my start. After 5 seconds, though, I can again use what I did before and say I could like guess and check it, or kind of just drag along here and find it that way. That's not your best game, though. Let's use V of 5. And then I'll also do V of 10 because I need that as well. So the next section, I need these two. And when I plug them in, after 5 seconds, you're going 50.6 feet per second. And after 10 seconds, you're going 69.17 feet per second. And if you look at the graph, it's like this. And the reason it's leveling off, so you can see how it's leveling off, this is called the terminal velocity. And that happens because when you're free falling, there's air pushing against you and it creates friction. If you're just falling and like, if there was no friction, like in a vacuum is what we would say, then you would keep getting faster and faster and faster. But since air is slowing you down, you're going to eventually hit a speed where you're not going to go faster than that anymore. That's your terminal velocity. And if you look, it's like 79.7, 79.8, and you keep going out here like 79.999999999. Okay, it's 80. All right, the terminal velocity is 80. So the fastest you're ever going to get is 80 feet per second. I think that's a question on your notes for you. I just didn't screenshot it. So the terminal velocity is 80. That's your asymptote. And you can see that right there based on that structure. So that's it for our graphs. So if you've got all that done, next up is going to be logarithms. So before we do logs, hit that like and subscribe.